Good morning all. Myself, Dr. Avinash K, Assistant Professor, Department of Chemistry, ATM College of Engineering, Mysore. In BTU syllabus, the chemistry lab, the applied chemistry lab for CS stream, that is BCHES 102202. Today we are going to see the experimentation on determination of chemical oxygen demand in wastewater. So first we must know what is chemical oxygen demand. Chemical oxygen demand is the test that measures the amount of oxygen or the oxidizing agent required to chemically oxidize the organic materials or oxidizable inorganic nutrients such as ammonia and nitrate present in the water. So this chemical oxygen demand is expressed in terms of milligrams of oxygen per liter, and the estimation of this chemical oxygen demand is based on the principle of redox titration, where reduction and oxidation takes place during this reaction. In this reaction, the dichromate what we take first oxidizes all the organic impurities present in the water during boiling. Further, the remaining dichromate solution oxidizes the ferrous ions from ferrous ammonium sulfate to ferric ions. So this is the principle. Okay, the amount of dichromate consumed will be calculated using the blank titration. The reaction involves the first oxidation of organic impurities in water. During boiling, by adding the dichromate solution, any organic compound present in the water in presence of sulfuric acid on boiling, it decomposes to give carbon dioxide and water. So further, the remaining dichromate solution will be titrated against ferrous ammonium sulfate, where the ferrous salt will be converted into ferric. Thus, it involves both redox reaction. The indicator is the 1,10-phenolphthalein, which is a red color, red in color. This ferroin indicator, when it has been treated with ferrous ion, it gets converted into a complex which will be bluish green in color. Later on, this blue in color, when it is treated with the potassium dichromate solution, the Fe2 plus gets converted to Fe3 plus, thereby the indicator gets converted into reddish brown in color. So the change of color from bluish green complex to reddish brown color will be the end point of the reaction. So these are the glassware which are required for our titration. Standard flask, conical flask, burette, and a 25 ml pipette, a graduated cylinder. Along with that, we need the chemicals like ferrous ammonium sulfate, potassium dichromate, sulfuric acid, silver sulfate, and a ferroin indicator. So here the ferrous ammonium sulfate will be the standard solution what we are going to use, and potassium dichromate, and we are going to use sulfuric acid because potassium dichromate acts as the oxidizing agent in presence of sulfuric acid, and silver sulfate acts as the catalyst to enhance the degradation of organic compounds. Ferroin indicator will be used to identify the endpoint of the reaction. So the standard solution of FA is prepared by dissolving around 4.5 grams of ferrous ammonium sulfate in 100 ml volumetric flask. We have to add a small amount of dilute sulfuric acid to enhance the solubility and to avoid the hydrolysis of iron. So here we have dissolved the crystal by making up to the mark in distilled water. Mix well and calculate the normality by using the following formula. Weight of FAS into 10 divided by equivalent weight of FAS. We get the normality of FAS what we have prepared. Coming to the experimental part, so these are the chemicals which are required, and these are the glasswares which are required for conducting the experiments. Initially, pipette out 25 cm cube of the given water sample into a clean conical flask. Transfer it into a clean conical flask. Later on, you have to pipette out the 25 cm cube of the given dichromate solution. So the dichromate will be transferred, 25 ml of dichromate will be transferred into the same conical flask to which you have taken the water sample. So if required, you have to take 50 ml, or depending on the condition, depending on the organic compound present, you have to take the dichromate solution. Later, you have to add sulfuric acid and the catalyst silver sulfate. Here we have taken the silver sulfate solution, which is dissolved in sulfuric acid. Around 10 to 15 ml of this catalyst solution will be added into the conical flask, and the conical flask will be kept for boiling for around 30 minutes. It has to be kept for boiling for 30 minutes. During this time, we have to prepare the standard FAS solution by dissolving 4.5 grams of FAS solution into the standard flask. Initially, add around 10 cm cube of distilled water to this. Rinse the funnel properly to ensure all the FAS salt has been taken into the standard flask. Add around 5 to 10 cm cube of sulfuric acid to enhance the solubility and also to avoid the hydrolysis of iron salts. Now, make up the solution up to the mark using distilled water. Make up the solution up to the mark using distilled water. Now, we can see that coming to the boiling, we can see that the solutions have started boiling. Allow it to boil for a long time so that all oxidizable impurities will be oxidized by the potassium dichromate solution. Once the boiling is completed, remove it from the hot plate and then cool it under the tap water. Cool it under the tap water. Once the solution has been cooled, now we can start the titration. Fill the burette with, first rinse the burette with FAS solution. The prepared standard FAS solution. So rinse it clearly so that any other solution or any other water sample present has to be removed. Ensure that there will be no impurities in that. Once you rinse the burette, fill the burette with the standard FAS solution what you had prepared. The burette has to be filled with standard FAS solution. Place the initial reading to 0. So the titration is ready. Now add around 2 to 3 drops of ferroin indicator. Initially you are not going to see any change in color, but once you add a small amount of ferrous salt to that, it forms a complex giving green color. So you can observe the bluish green color. Note on the initial reading and see the change in color to bluish green. It has become bluish green. And continue the titration until the color changes from bluish green to reddish brown. It gets converted to reddish brown in color. Once the solution becomes reddish brown, stop the titration. See, the color changed to reddish brown. Now stop the titration and note down the end point, the volume of FAS solution consumed here. In this case, the dichromate has already used for oxidation of organic impurities, and we have obtained only the remaining dichromate solution. So we have to even perform a blank experiment where we are going to take the same quantity of dichromate which we had taken in the previous step, around 25 cm cube. It will be transferred into the conical flask, and ensure that we should not add the water sample here. Once it is added, we have to follow the same steps. We have to follow the same step as previous. We have to add the sulfuric acid mixed with silver sulfate solution, and we have to keep the solution for boiling for half an hour. Add silver sulfate with the sulfuric acid around 10 to 15 cm cube. After adding, keep the mixture for boiling for around half an hour. So we have to follow all the same similar step which we had performed in the previous one. Once the solution has been boiled, cool it under the tap water and you can initiate the reaction. So by initiating, note down the initial reading of FAS solution. Note down the initial reading and add around 2 to 3 drops of ferron indicator to it. Ferron indicator. Continue the titration until the color changes from bluish green to reddish brown. So once reddish brown is formed, stop the reaction and note down the end point of the reaction. Note down the end point of the reaction. End point of the reaction. In previous step, around 11 ml was consumed. Here 13 ml has been consumed. Means around 2 ml has been consumed to utilize for the oxidation of organic compounds. So during this reaction, it's very important that you have to note the colors properly. So initially when you take wastewater, it will be colorless in nature. Once you add the dichromate, the solution becomes orange, and after boiling and cooling, the orange solution will become slightly pale in color, pale orange. Later when you add FAS solution, the color changes to when you add indicator and FAS solution, the color changes to bluish green. At the end point of the reaction, it gets converted to reddish brown. Now, after noting down the end point of the reaction, by using this calculation, you have to identify the amount of iron consumed. We will be having one back titration and blank titration, that is B, the back titration, and C will be the blank titration. So C minus B will provide you the amount of FAS consumed. So by knowing the amount of FAS consumed, we can identify. So we know that 1000 cm cube of 1 normal FAS solution can consume around 8 grams of oxygen. Hence the VCM cube, what we have obtained of Z normal FAS solution, can consume around V into Z into 8 divided by 1000 into 1 dash grams of oxygen. So this will be for 25 cm cube. Later on it will be converted to 1 liter, which gives the amount of the mg of oxygen per liter of oxygen required to oxidize the organic compounds present in the wastewater. Thank you for